Hi grade 11s. What this is now is this is topic 3.10, which is the end of the reduction section. So we've done all the types of reduction that we can, and now what's left for us is to practice quite a lot. Now we're going to focus on co-ratios in this video, simply because that's probably the most difficult of the reductions, and we're going to practice a whole bunch of reduction questions, and then hopefully this is a topic in Trig that we'll really enjoy. So let's look at some examples together. First example says, write cos 160 degrees as a trig ratio of an acute angle. So basically we need to rewrite 160 degrees. So cos 160 degrees, we could rewrite that in two different ways. We could write it as 180 degrees minus 20 degrees, or we could write it as 90 degrees plus 70 degrees. Both of those involve an acute angle and one of the axes. And now we need to do our reduction. Now don't forget that reduction comes down to two steps. The first step is we need to figure out the sign of the reduction. And the sign of the trig ratio depends on what quadrant you're working in. So if you're working with 180 minus something, you're going to be working in quadrant 2. And cos is negative in quadrant 2. So my first step is done. My second step is to work out what ratio am I working with? What's the name of the ratio? Now this ratio says cos, but I'm working from 180 degrees. So either your name is going to stay the same or it's going to change. Now if you're working off 180 degrees, your name stays the same. So this reduces to negative cos 20 degrees. Now it just said I had to reduce this to a trig ratio of an acute angle, which is done. I don't know what cos 20 is, but it's not a problem because they just asked us to reduce it. Okay, if we go to our other side, I'm going to follow exactly the same steps. The first thing I need to discuss is I need to decide what is the sign of this answer going to be. And again, that depends on what quadrant we're working in. Now 90 plus means I'm working in quadrant 2. And as we've just said, cos is negative in quadrant 2. So the next step is to decide on the name. The original ratio is cos here, but I'm working off 90 degrees. And the moment you're working off 90 degrees, cos will change name to its co-ratio, which is sine. So this reduces to negative sine 70. Now this might now look that you have two answers to the same question, but these two are equal to each other. Now the reason you'll know that these two are equal to each other is this is exactly what co-ratios means. These angles are complementary. 70 degrees and 20 degrees add to 90. So we say they're complementary. So sine of an angle is equal to cos of its complement, simply because of reduction. So those actually are equal to each other. Right, let's try another one. This is a particularly interesting question. This question says, given that angle A plus angle B is 90 degrees, where angle A and angle B are acute, and given that sine of angle A is equal to 8, well 17 sine of angle A is equal to 8. Now this looks very similar to the Pythagoras type questions that we were doing right in the beginning of trig, in that I can now figure out what sine of angle A is. Sine of angle A is 8 over 17. Now I was told that angle A and B were both acute, so basically I'm working with something in the first quadrant, which means I can figure out, I'm not going to write it there, I can figure out what is x, what is y, and what is r for this angle of A. Now let me just work with the signs first. Don't forget that we always find the quadrant because that tells us the signs. Now this is quadrant 1, which means x is positive, y is positive, and r is always positive. Now sine by definition is y over r. So I can immediately fill in the fact that this must be 8 over 17. Now I need to find x. So either I can show all of my Pythagoras' theorem. I happen to know that there's a Pythagorean triple, which is 8, 15, 17. If you don't know that, you'd have to actually do Pythagoras, but you don't actually have to show any working. So I know that x is equal to 15. Now what this means is that any trig ratio of angle A I can work out, because all you need is x, y, and r. The only problem is this x, y, and r is only got to do with angle A. So I can work out anything about angle A, but I don't know anything about angle B. So if I look at the first question says cos of A. Now that's not a problem. Cos by definition is x over r, so I can immediately tell you what that is. But it says plus sine of angle B. Now the only problem is I don't know what angle B is. Now I'm not allowed to use a calculator, so I can't find angle A and then figure out angle B, and I don't have x, y, or r. So what's the only thing I know about angle B is I know that angle A plus angle B is equal to 90 degrees. So if I know that angle A plus angle B is equal to 90 degrees, how can I express angle B? Well, then angle B would be equal to 90 degrees minus angle A. Now that's quite useful to me because I know everything about angle A, and so if I can write angle B in terms of A, that's going to be really useful. So if I go back to my question, this is going to equal to cos of A, which I actually do know the answer to, and this is going to be sine, and instead of writing B, I'm going to replace it with 90 minus A. Now cos of A I'm still going to keep around. Now this next part is reduction. So I know that reduction has two steps. First of all, 90 minus A is in the first quadrant and everything's positive, but I'm working from 90, so sine will change name to cos. Now all of a sudden I realized I wrote a B here, which was silly because this was A the whole time. So basically my sine of B is exactly the same as cos A. Now we should start to notice that because A and B add to 90. So we've started to learn this co-ratio. If I scroll up to this question here, we know that sine of 70 is the same as cos 20 because those angles add to 90. And this is the same idea. I now know that sine B is the same as cos A because A and B add to 90. So that's the whole idea of my co-ratios. Now this is great because cos of A is very easy. I know what x and r are. So x is 15, r is 17, so basically I get 15 over 17 plus 15 over 17, which is 30 over 17. So really nice question. It's a bit of a Pythagoras one, but with co-ratios built in. So if I continue on to question B says sine of 180 degrees minus angle B. That's not a problem. I'm going to do reduction. Don't forget, it comes down to two things. First of all, what is my sine? I'm working in quadrant 2 because 180 minus B, which means that sine will be positive. And my name is not going to change simply because I'm working from 180 degrees. Now, I don't know what angle B is, so this isn't particularly nice. However, I do know that I can rewrite angle B as 90 degrees minus angle A. Exactly, actually, how I did it here. And I now know that because I'm working from 90 degrees minus A means quadrant 1, so this is positive, but my sine ratio is going to change to its co-ratio of cos. And so this again is 15 over 17. So really nice connection here with reduction. Right, let's move on. Question 3. So question 3 is all about these stereotypical reduction questions that they give you in exams. Now don't forget, every single reduction comes down to two questions. First of all, if I look at my numerator here, I ask myself what quadrant is that in, and 90 minus is quadrant 1, and everything's positive in quadrant 1, so the top is positive when it reduces. I wouldn't normally write a plus sign, I'm just writing that for our notes. Then if I'm working off 90, which I am, my name changes, so cos will change to sine. Over, what quadrant am I working in? 180 plus theta is quadrant 3, and sine is negative in quadrant 3, but my name still says sine because I'm working from 180. And so that simplifies, the signs cancel, and I get negative 1. Right, let's move on. Question B. Sine of 90 degrees plus alpha. First question you ask yourself is what is the sine of what's happening? And that depends on our quadrant. So if I have a look at this, 90 plus alpha will be in quadrant 2, and I'm talking about sine, and sine is positive in quadrant 2. The second thing I look at is I look at my name. Does my name stay the same or does it change? When does it stay the same? It stays the same if you're working on a reduction from 180 or 360, and it changes to its co-ratio if you're working from 90 or 270. But remember, 270 isn't necessarily examinable. So in this case, I'm working from 90 degrees, and so sine will change to cos. So now I start the same process again. 360 minus alpha is in quadrant 4, and tan is negative in quadrant 4. But I'm working from 360, so tan will stay tan. So it's negative tan of alpha. So normally, at this point, that's an acceptable answer. Now, I've been hinting at our next section, which is actually identities. And in identities, something I've been saying quite a lot of, and something we're about to go and work with, is the fact that tan of alpha is always going to be the same as sine of alpha over cos of alpha. So our next topic after reduction is identities, and we're going to look at proving why that is true. So what I can do here is change this tan to sine alpha over cos alpha, because it allows me to simplify. So if I look at what else I have a positive times a negative, which is negative, and I've got cos alpha there. And so actually what's going to happen is my cos alphas will cancel. So technically that cancels. Now when you cancel things, try not to scribble, because we need to be able to see what you were doing. So this simplifies to negative sine alpha once the coses have cancelled. Right, onwards and upwards. Sine squared, interesting, I'm squaring, so let me put that in already. And remember, 2 steps. I first ask myself the sign, and then I ask myself the name. So the sign, well, 90 minus x is quadrant 1, and everything's positive in quadrant 1, so this is just sine. And my name, oh, no, let me take that back. Sorry, I meant this is just positive. Now I'm looking at my name, and I'm working from 90 degrees, and so my name actually changes to cos. So this is cos squared x. So moving on to the same concept, so this is plus. Now I'm squaring. 360 minus would be in quadrant 4, and sine is technically negative. Now I know I'm going to be squaring this, and so that negative really is not going to play a role, but always show the negative and then square it. And my name is going to stay sine because I'm working from 360. So this is negative sine x. So this actually becomes cos squared x plus, and my negative gets squared, so plus sine squared x. Now again, at the moment, that's a perfectly acceptable answer. However, one of the identities which I haven't been referring to a lot, and we're going to prove it in our very next section, is that cos squared plus sine squared, or sine squared plus cos squared, is always equal to 1. Now I noticed here, I don't know if you noticed, but I don't know why I wrote alpha. Sometimes we often do this, we make mistakes by putting different angles in. These angles were both x. So just notice, if the angles are both x, then cos squared plus sine squared, or vice versa, is always equal to 1. So this will actually simplify down to 1. Now I've put an asterisk there because that's not something we know yet. In fact, I think we've only seen that once so far this year. So we'll discuss that in depth in our next section. We're also going to discuss why that is true, and then I think it makes a lot more sense. Okay, on to question D. Again, we're squaring, so I'm going to square, and we've just got to keep doing our 2 steps. So first of all, what quadrant is this? 180 minus is quadrant 2, and cos is negative, but I'm working off 180, so cos will stay cos. So this is negative cos beta all squared. This will be over sine, and 90 minus is quadrant 1, and so this is going to be positive. And sine, however, is going to change its name to its co-ratio of cos, simply because I was working from 90 degrees. Times by 180 plus an angle is quadrant 3, but we're talking tan here, so tan's positive in quadrant 3, and I'm working from 180, so that name stays the same, so it's tan beta. Now again, we have this whole thing of tan, and we know from lots of experience now that tan is exactly the same thing as sine over cos. So in order to simplify this further, I'm going to replace this with sine of beta over cos of beta. So this top is actually cos squared beta, because the negative got squared, and this is over cos beta. And now I can do some cancelling, because one of these causes will cancel with one of the causes, but then there's another cos. So basically I have cos at the bottom, which is cos squared. And so I land up with cos squared at the top and cos squared at the bottom. So this simplifies down to sine beta. So all of those are pretty standard reduction questions, and that particular reduction question will probably be worth about 5 marks. So they really are nice questions to score marks in. Okay, let's look at question 4. Some more simplifying and very stereotypical co-ratio questions. So simplify without a calculator. Now the moment I look at this, we've always been working with special angles. And I look at this and I see sine 33 and I'm like, 33 is not a special angle. And there's no ways that 33 can be a special angle. And then I look at the bottom and I see cos 57. And I'm like, that's not a special angle. And whenever you see angles that there's no ways you can rewrite them using a special angle, chances are there's a partner somewhere. So if you look at sine of 33, can I rewrite 57 using 33? So you always have to keep one of them. You can't change both of them. So if I keep sine of 33, can I rewrite cos using... So can I rewrite my 57 using 33 degrees? Simply because then perhaps there'll be some cancelling that can happen. So can I rewrite 57? Well, 57 would be 90 degrees minus 33. Now that's wonderful, because that means my top stays the same. But if I do reduction on the bottom, 90 minus is quadrant 1, and everything's positive in quadrant 1. But cos will change its name to sine because of the 90. So this reduces down to sine of 33. And what do you know? They'll end up cancelling. So I can promise you, if there's any angle that is in a question that's not a special angle, it's probably going to land up cancelling with something else. So you just have to find out where its partner is. Okay, let's have a look at the next one. If I look at the next one, sine of, and there's 322. Now there's no ways that's going to be a special angle. And then there's 128. So basically I need to look at 322 degrees, and I need to look at 128 degrees, and I need to find out, can I rewrite both of them and to an angle that is common? So can I rewrite 322? Now why am I trying to rewrite both of them here, whereas in the previous question I chose not to rewrite the 33? And the reason being, 33 was acute, and so we like acute angles. Neither of these angles are acute. So what axis is 322 closest to? 322 is closest to 360. So this will be 360 minus 38 degrees. Okay. So now can you rewrite 128 using 38? Now you could rewrite 128 as 180 minus or 90 plus. So if we wrote 180 minus, it would be minus 52 degrees, I think. Now Doogie, that doesn't match. So, or I could rewrite it as 90 plus 38 degrees. And so what you notice is that these two have something in common. And so I'm going to choose that. So this I'm going to rewrite as negative sine, and this is 360 minus 38, and 128 I'm going to rewrite as 90 plus 38. So now if I do this one, 180 minus 38 is quadrant 4, and sine is negative in quadrant 4. So I have negative, and now this is negative, or you could just cancel out the negative. And because I'm working from 360, my name stays the same, So this is actually going to land up being positive sine 38 in the long run. If I look at the other side, 90 plus means quadrant 2 and causes negative in quadrant 2. But my name is now going to change. So this is minus sine of 38. And so what do you know? Didn't I always say there'd be a partner and it'll probably cancel? Because sine of 38 minus sine of 38 is nothing. And the nice thing is you weren't allowed a calculator, but you can always check on your calculator once you finish to see if you were right. Right, let's soldier on. Question C. First thing, I see my reduction there and I say, right, 180 minus alpha would be quadrant 2. Sine is positive in quadrant 2, and because it's 180 minus, that's sine of alpha. Multiplied by cos 68. Now, 68 degrees is not a special angle, but it is acute. And so for now, I might as well keep it until I figure out what's going on. Now, if I look at the bottom, I see sine 22. Now, that is acute, but I'm guessing that the 22 and the 68 have to be related because they're both not special angles. So how can I rewrite 22, hopefully using 68? I can rewrite it using 90 minus 68 degrees. Now that'll obviously reduce to an angle with 68, which is good for me. Multiplied by cos, 360 minus alpha is in quadrant 4, and cos is positive, and my name stays the same. So cos alpha. So this is going to stay sine alpha, cos 68 degrees, all over. And now I can do reduction. 90 minus is quadrant 1, so cos sine is positive, but he changes his name to cos. So cos 68 degrees, and then we can see we've got our partner. And then I've got my cos alpha. So what do you know? My cos of 68 cancels with my cos of 68, and I'm left with sine alpha over cos alpha. Now at the moment, that again would be an acceptable answer, except I'm pretty sure this is like the 15th time we have noticed that sine of alpha divided by cos of alpha is actually the same as tan of alpha. So you'll see how often that comes up. So I've just written my note of my identity in there. Okay, last example for this video before we watch a slightly different one. Let's do some reduction. 90 minus is quadrant 1. Sine is positive, but it's 90, so I change its name to cos. On to the next factor, cos of 17. It's not special, but it's acute, so I'm going to keep it for now. And now my denominator, I'm hoping I can rewrite 107 using 17, because it must be somehow related, and I can. It's 90 degrees plus 17. So I've got my cos theta, my cos of 17, and now this bottom is going to reduce to 90 plus is quadrant 2, but sine is positive, but sine is now going to change to cos. And so, yep, those cos 17s cancel, and I'm left with cos theta. So you'll notice in all of these questions, the moment you have something which isn't a special angle or anything that you can work with, I promise you there's a partner lurking somewhere that it's going to cancel with. Okay, this has been a marathon video, so we're going to hit pause. I think you need to take a jog on the spot just to wake up a bit, and then we'll continue just with 3 more examples.